In this video, we present the use of target assistance techniques for improving game balance between players of different skill levels. In games where skills such as aiming and targeting are critical to winning, it is difficult for players with different skill levels to have a competitive and engaging experience. For example, allowing children to compete against their parents or friends of different skill levels to play together. To address this problem, we propose the use of target assistance techniques to improve game balance. In our study, we compared 3 target assistance techniques in a 2-player shooting gallery game. The goal of the game is to score the most points by shooting on-screen targets as quickly as possible. Players use a Wiimote as a pointing device to aim their cursor. A player scores 1 point for shooting a target and loses 1 point for each miss. To demonstrate the 3 techniques, we use a customized version of the Wii remotes used in the shooting gallery game. Our modified pointing device combines both Wii remotes. A whiteboard eraser is used to separate the 2 controllers. Combining the Wiimotes allows us to move them both simultaneously. Next, we plug the sensor bar for the Wiimotes into a computer running the shooting gallery game. Here we see the Wiimotes and their associated cursors moving in unison. This setup is used only to demonstrate our target assistance techniques. When playing the shooting gallery game, each player operates their own Wiimote. We chose 3 techniques, which have been considered in previous research on target assistance, for comparison in our study. We now demonstrate the techniques using our modified pointing device. Sticky targets change the effective target width by adjusting the control to display ratio when the cursor is on a target. Here we see sticky targeting applied to the red cursor on the left. No targeting assistance is applied to the yellow cursor on the right. Note how the red cursor travels more slowly over the targets. Target gravity provides attractive force on the cursor towards all targets on the screen. Closer targets exert higher force. Here, target gravity is applied to the red cursor, while no assistance is applied to the yellow cursor. Notice how the red cursor warps towards the targets. Area cursor increases the size of the affected area when a shot is taken. Here we see area cursor applied to the cursor on the left, while the yellow cursor on the right behaves normally. Note how shots taken slightly off target by the red cursor are registered as hits, while any shot taken off target by the yellow cursor count as a miss. We investigated applying each of the techniques adaptively. Here, when the difference in score is 0, there is no assistance given. But as the red player falls behind, the level of assistance is scaled up. Notice how the red cursor has started to display characteristics of target gravity. Such an approach would allow the assistance to be applied only when it was needed. Our comparison of the 3 techniques found that area cursor and target gravity significantly reduced score differentials in the shooting gallery game. Target assistance improved the fun of the assisted player without having an impact on the unassisted player. In addition, players did not notice the assistance and felt that this form of balancing was appropriate for group gameplay. Our results show that target assistance techniques can make target-based games more competitive for shared play.